Share, okay. Okay. Okay, can you see everything is ready? Can I start?
Yes, go ahead.
Okay, so in this presentation, I decided to tell you how the corporate project works, okay, and how we are stuck. But I said, okay, Nijati, like, what's a corporate project? It is a data science workflow, and each step has a different challenge. So I realized I should explain each step one by one, and then give one example about Claro so you can understand what's going on. So the first, so this is the workflow, okay? Something I probably mentioned a couple of times. Like you collect the data, you investigate and understand the data, you merge the data, you process and make it ready for the algorithm, and you run the algorithm. And meanwhile, of course, you also clean the data. And cleaning is not something like, okay, I cleaned, it is done. No, like, because you can find a problem while you're investigating data. You can find a problem while merging the data. You don't know when you will have the problem. So you will see there are three arrows here. Like, what does it mean? Because generally, when you run the algorithm, there's an iteration phase. You run the algorithm, you don't like the result, and then you can pre-process the data. You can say, okay, I will use another data, so I have to make a merge again, or you see that your hypothesis is wrong and you have to go to investigation phase again. So it is completely based on what kind of issue you will experience in the problem. So that is why I prefer to say it's a cycle, an iteration, rather than a single straight line. So what is the issues with collecting data? We have data from multiple sources. I think that is something we experience it a lot, and I am sure that is the point that everybody will understand without a problem. We have a data source from multiple sources. It can be an Excel file, it can be a database, it can be a text, it can be a CSV file, and you need to somehow put them into same medium. When I say medium, it means, like, for example, database, and make it run. Sorry. Now we collected the data. What are the challenges here? The challenges is you have to upload to download data. You have a 5 gigabytes of data, and you have to download it from customer's database, or for example, he shared from Google Drive. Then you need to upload it to BigQuery, because we are using BigQuery. And while cleaning, while uploading, there will be some issues because BigQuery requires structured data. I know there are a lot of terms here, but it will be, just stop me and ask, okay? So these are the challenges we will have. But generally, collecting data is the first step, and putting them into a standard medium is a challenge. At least is the most easiest challenge, to be honest. Like, although we have this is a big challenge, because once you have 100 gigabyte data, upload and download, this is a challenge. Go ahead, please.
One second, just to remind terms, and I'm going to explain it from my side, because it's how a non-technical person could describe it, and I think they will understand. Is just to remind you all, Google, for example, or how would I say it? Like an Amazon S3, for example, is a bucket where you can have a CSV file, but then when you have a Google BigQuery, it's more like a database where you have structured data. So it is very important to have that differentiation, because you might have a CSV file in a bucket, but for us to be able to process all of the data, the client needs to move either the CSV file from the bucket to our BigQuery. Now, many clients would ask, or say, I don't want to move my data from my bucket to BigQuery. What me and Nejari actually discussed yesterday is that either way to run algorithms, you would have to move your data, because you can't run algorithms in a bucket. You can't run it in an Amazon S3 because it's just a CSV file sitting there. So you will always have to move that data from, for example, a bucket to a BigQuery. And I don't know if I'm being correct, Nejari, but for example, what is the equivalent in Google of a bucket?
It is Google bucket. Like Google has a bucket.
Okay.
Yeah.
Can I run an algorithm in a Google bucket?
So yesterday we were discussing something else. Like, let me make it clear, because you can fetch the data from bucket and run the algorithm. Yesterday's discussion was something else. Let me remind you. There is a data here sitting on your, for example, MS SQL server, Oracle server, in your server, in your computer, okay? Then you decided to run a machine learning algorithm which will not run on your database server.
Correct.
So what you decided, okay, I need to somehow copy this data, process and copy data to Amazon or Google. So you have to move anyway to run the data, to run the machine learning algorithm. So, but some tools, let's say, for example, with some tools, of course, you can directly fetch from bucket. But if you look from the wider perspective, the standardization is important. What is the standardization and what is the medium that we will work on? We are working on Google BigQuery medium. Like, that is the environment we are using. That is the environment that you visualize your data, you make your query, and that is the environment that you run the algorithm. Like, you fetch the data from that place. So that is our pipeline's initial point, initial starting point.
So just to go back, if a client has data in an Oracle database of their customers, right? And they have data from the call center in, I don't know, a CSV file somewhere else, and they would like to run a machine learning algorithm. The process would be, hey, I'm gonna build a data lake in, let's say, a Google bucket, right?
Yes.
So I put all the data there. Then the process would have to be cleaning that data. So I have a question. Cleaning that data and aggregating that data from, once you have it in the bucket, do you have to move it to BigQuery if you were the client trying to clean and aggregate the data? Or could they do that in the bucket by itself?
It depends on my problem, but like, I can do a couple of things without moving from bucket to BigQuery, and I can do things, and I should move for some cases to BigQuery. Like, for example, if I know that is something that I have a data warehouse team, like, because there are some companies that they have only data warehouse team. They don't use buckets. I never seen a data warehouse team that uses buckets. But sometimes I saw that people move from BigQuery to bucket. because some tools allow them to use machine learning algorithms from the bucket.
So usually to clean and aggregate data, they move it directly from an Oracle database to BigQuery, straight to BigQuery.
Yeah, you can say something like that.
Got it.
Yeah. Because like I never seen a data warehouse working with directly buckets, but as I said, it is also can be an option, but it is not. Yeah, the data should be anyway structured. So
first conclusion, when we talk about a data warehouse, it's usually data that it's in something like BigQuery, if it's Google.
yes, you can. Yeah.
Okay.
Yeah, Google BigQuery calls himself data warehouse.
Okay.
Okay, so that is the collection phase.
Excuse me, just a quick question. When
Of
you
course.
say that you move the data from one place to another, for example, from the bucket to BigQuery, does that mean that the data will be now stored in BigQuery? It changes
Copy.
the place where
Let's
it's
say
stored? It's copied.
Yeah, copy. The copy is the correct term.
Okay.
Yeah, you are right.
Thanks.
Thanks for fixing us.
But that's a good question. If it's a copy, is it also stored in BigQuery, or is it stored in the bucket and you just fetch directly from the bucket? I would say stored, because if most data warehouses are directly in BigQuery, you could store it just in BigQuery.
There are a lot of use cases, so I'm trying to think which one is the use case. Okay, so in our case, we are copying because we are not dealing with customers' database. We don't want to we don't want customer to use BigQuery as his main database. So we are copying, but there are some companies, like for example, they move their old data to warehouse, not to make the main database busy. Now, by each year, for example, they move the data from one place to another, so they don't, because they know that the old data will not be used. So they move, like literally move, like delete this data and move there. And so they will, what is the goal? The goal is the new database will not deal with the CPU usage of old data.
So in the case of Claro, Nejari, where do we have their data stored?
BigQuery. Like we uploaded everything to BigQuery, yes. Okay. Yeah, that was a good question. Like, because data warehouse usage is like, I think people use in multiple ways. Some people move, delete the old data and move them to a warehouse. Some people just to make the analysis or to run the algorithm, move it to somewhere else. Okay, understanding the data, investigating data is the second phase in in the data science workflow. First of all, you have to understand the data. Like, what is this data about? You don't know. I don't know. Who will know? We need to learn. Okay, so how the data is stored. And I gave here a couple of examples, and you will understand then what I'm trying to say. Yeah, it's here. In this case, I tried to explain how user table, user, invoice, and products can be stored. Okay, you will see there are multiple ways. Some of them are bad, some of them good. But my idea is like, let's put them so you can understand why understanding the data set is an important phase. Let's say Nejati purchased dress and shoe from an e-commerce company. And how will the invoice information will be stored in the database, in the table. Let's say this is one table. Don't think it's a table. This is Excel file. Okay. How will be stored? Okay. Necati user ID is 1, name Necati, invoice ID 1, invoice date January 1st, what he bought, dress and shoe, what is the ID, product ID 1, 2. Okay, that is a one way, easiest way. But what is the problem here? If Necati comes next day, I have to copy Necati's name again. And now if he bought another shoe, so do you see the issue here? Now, technically, you are populating your data with the same information again and again. Like, we don't like to do it. It is not a common way. But I am just making it here so you can understand the different ways of storing data. So because you should not, like now, what is that? 1, 2, 3, 4, 6. 6 bytes. Like if I have millions of billions of bytes means gigabytes of data. Like I am just putting the same information again and again, and it is making the database slow and fat. So that is one way, which is not it's not common. Like sometimes you can see this kind of stuff. It is also not common, but it's something you see. The developer decides to create 3 tables. 1, user table. 2, product table, which makes sense so far. Then invoice table. Here is the invoice. Here is the invoice date, and here is the product ID. Oh, what happened now? And also user ID. And what happened now? I am not repeating. If Necati comes tomorrow, again, I am not repeating Necati's name. Although I am not repeating Necati's name, I can know where is Necati. It is like I can make cross match here. Again, don't think this is a database, it's an Excel. Like how do you store this information in the Excel? Again, yeah, that's a good way of storing information. If Necati is coming again tomorrow, I will not store the information again and again. Next day he came, bought another product, and okay, perfect. We solved the problem. But what we didn't solve? We didn't solve the issue of product ID. Now I don't, if I want to select only the invoices which has only dress, like which has dress, not only dress, but which has dress, like how will I do it? Because again, don't think this as a 2 row. It is a 1 billion row, okay? So how will I find which contains the dress? You can say Necati 1, 2 is here. Like 1 is here, I can see it. But if you store like that, again, the search time will be huge because you can't just say, show me the columns with 1. Like even let's make a filter here. Like it is very here, easy, right? Like I don't remember where is the filtering. Let me try. I want to show this stuff so you can understand, hopefully. Okay, filter.
It's the icon on your right on top of
create filter. I saw create filter. Okay. So do you see now? I have this Excel file. Now I want to see the invoices that has 1. How will I do that? Like there is no option here. 1, 2, 2. Where is 1? How will you do it? There is no way to do it. Now that is why that's also not a common way. But sometimes you can see, well, that's not a common way. Now let's go to the next one. This is the user ID, user table. That is the product table. That is the invoice table. Do you see now I stored the invoice information, user information, and invoice date. And then I created another table that shows one by one which invoice has which product. Now I solved the other issue. Like I can see which product has only which has product has one. Okay, here it is. So like I am just trying to explain the logic behind it, why people are creating so many tables, because that is how you make it, let's say, flexible. Now, what is it to do with us? The problem is I need to know where the customer user information is. I need to know where the product information is. I need to know where the invoice information is. I need to know where the invoice and product information is. I need to know if the customer stored in this way or in this way or in this way. And it is one of the, again, one of the simplest examples. Like you can think more complicated, like start dates, end dates, subscription. How the customer is storing the data? I have no idea. I have the data. I need to learn that. That is why each time we are asking the customer, what is the meaning of that column? How did you, why did you design that? We need to understand the data.
So Nejari, in those terms, we should have two scenarios. Like the first scenario where we need to do a lot of manual work because the system is still not finished. And in that case, if the client has a data scientist, shouldn't they have a document where they have explained how did they organize their databases so that somebody that is external can understand, or usually they don't have those type of documents?
No, they don't have.
Okay, and two, if once our system is fully automated, the person that should do this work is that data scientist uploading all the data into our system, right? Because if we want everything to be fully automated, then doing this always is not sustainable, correct?
Yeah. So this stuff, like first of all, once our system is fully automated, there is no uploading and downloading because we will automatically fetch from his database. And if they don't change the database structure, like we will use the same SQL query. So he will run the once and he will continue using the same query if they don't change the database structure. For example, in this case, like if you don't change the database structure, what I am doing is like adding more lines here. So it is always, I know that this product ID is the combination of this, the cross match is this product ID. So I know that. So you don't need to make this every month. You will do it once and you will run the pipeline. Actually, that's what we did with Claro. Like I think we made zero or a very small modification in this phase. Like when I compare with the previous data set and new data set. This is the step that can be automatized properly. Okay. So I emphasize this because I wanted to say like we need to learn the data. I don't know how they store the data. Okay, so what else we can see? Sometimes you don't ask the customer. Like I don't need to ask because it is easy sometimes to understand which is each. But like you have another challenge, like the information is stored in different ways. Again, it's still not a challenge, but it's something you should see with your eyes and understand what is what. Detecting outliers, you investigate and you see there are problems, and you can investigate that. You can find these issues while investigating, while merging, or while running the algorithm. Like you don't see there is a problem, then you run the algorithm gives error, and you realize that one of the date columns is wrong. Another issue about, like, we are dealing with ID generally, but let's say I don't have an ID. Now you have another problem, like Necati Demir and Necati Demir. So they entered information wrong in different tables. That's something need to be handled. Okay. The previous example in the Excel file I showed you is a clear example of merging issue. I need to understand the data so I can merge it. And each scenario is merged differently. If I will do it, I need to learn. But if a real data scientist will do it, I don't need to learn because they will just do it. Okay, process. Now I clean data, I assume I process, I merge data, I know the data. Now I need to understand. I need to process the data to make it ready for the algorithm.
Nejati, just sorry, 1 second. To merge the data is just an append command in the SQL?
No. It is join. You join.
Okay.
Join. A comment, like basically it's called join. Okay. So I want to process the data because I want to make it ready. Like I have the raw data, but how will I make it ready for it? Now this is something again when we discuss. Okay, Nejati, our goal is to make it ready. Like our goal is to predict next 10 days if the customer will churn next day. Okay, what is the input? Here is the data, but how it is processed? Now it is completely based on our imagination, data science imagination, my imagination, and our discussion and brainstorming. Like what kind of features we can use to make the prediction. You can't just say, okay, here's the raw data and use it. Like the algorithms are not intelligent. They are algorithms anyway. So if I want to predict the churn in the next 10 days, what kind of information I should use? What is the definition of churn? The first problem. I think we made this discussion, right, Daniel? Like we said, what's the definition of churn for customers? Not using phone, not using voice, not using text, not using internet, or both, or one of them. What is the definition of churn? This is one of the things. How many data points should I use? Like these, I mean, this process is so hard to explain because it's changed from data to data, and like it is completely based on imagination and art. Should I sum? For example, I want to analyze the number of minutes. Should I sum? Should I take average? Should I use both? Should I include how many days he talked in 1 month? Should I use or should I use the how many days he used the phone or not? The days that he didn't use the phone. Or maybe all of them. Maybe only on 15 days. Like these are the processes that causes iteration. I don't know. Do you know the answer? Nobody knows the answer here. I also don't know the answer. Our goal is to make it like produce as much as we can in terms of our time slot. Like I need to make it ready today. So of course I can't spend time to make the process 1 month. So I should be very quick.
But
let's go ahead, please.
Thinking about our automated project, we should, like in our UI or UX, start doing all these questions to the person that is uploading the data, so they will be able to do it by themselves, right?
No, you cannot ask. You cannot ask. Again, this is something like this is only Claro. What about another data?
Exactly, but exactly when another client enters, you say, I want to make an analysis. So which columns will you take? Then which, so if I say I am Telefónica and I want to make a churn analysis and I upload my data, how will they know how to make the process correct? So when they put, I want to make a churn prediction, the system will take the columns that they should as a client understands churn. How will that be automatic or delegated to the clients in the interface?
We will delegate to the data scientists. We will delegate this to data scientists, not to marketing people.
So we will always have support for that.
We will always have to intervene. Yes, yeah. I mean, maybe we can decide to implement a specific operator for a specific customer. So he will not, he doesn't need to make the change again and again. But eventually each customer is different, each data is different. And here is the point, Neti. Do you think this data came like this is the raw data? No, I am getting this, I am calculating this information from the raw data. It is not a column. It is not a column in the Excel table. I am taking the average, sum, I am making another calculation, like blah, blah. So you have, I will give another example, a clear example, I think next, or the other stuff. You will understand, like, we are not just using the raw data. We are making changes in the raw data.
Nati, but I want to understand why you say we always have to have support for that, because what's going to happen is that the data scientist is going to upload the data. They're going to have the columns, and he's going to have to be able to ask the questions beforehand of what columns he's going to need to be able to run the analysis. If he doesn't know how to do that, he's not a data scientist. So we would they would have to hire us so that we can help them and figure these things out. Like in the case of Claro, right? They didn't know how to do a churn analysis. So it's us doing everything for them.
Yeah, so that's my point when I talk about the client. The data scientist of the client, not from us.
Correct.
If we can do it, yeah. The customer data scientist also can use our product without a problem.
So that's why I'm asking if that steps or something should be in their interface, or they should do all this process before starting using our software.
No, they can do it on our user interface. But we will not ask these questions. They will do it by coding, by SQL coding, or maybe with some different tools we provide, because we will not ask the exact this question. We will provide more general tools a data scientist can use.
Let me give you an example, Nati. It's like Photoshop. Photoshop doesn't ask you before you use Photoshop, what do you want to draw? Before you draw, think on the hair of the person. No, right? It's just a tool to draw. In our case, it's a tool for a data scientist.
Good example.
Okay.
Okay, so running the algorithm. Okay, this is actually one of the simplest parts. Like running the algorithm is only one part. Of course, we have problems here too, but there are also challenges. Each parameter has each algorithm has a different parameter. Like, how will I decide this? Again, we are doing this based on experiences, but this is also why there is an iteration. Let's use, I am using a decision tree algorithm. Like, decision tree can be very deep, or it can be very short. Like, how will I make the decision? I know that by experience, if I make it very deep, it will not make a very good prediction. But if I make short, it will, I will not use the power of decision tree very good. So this is why this was another decision. Okay, so specific problems to Claro in each step. Collecting phase. We received the data in 8 different CSV files. These are the biggest files. Biggest 4 files, 15, 10, 11, and 10 gigabytes. 50 gigabytes, almost 50 gigabytes of data. You are downloading to a data science computer and uploading to BigQuery from data science computer. Okay, do you see the point?
That for sure crashed the computer like 10 times.
Yeah. So I remember just uploading one file took 8 hours, and he left the computer at night, like came back, and for example, once he saw problem, and you can imagine like 50, just try to download to your computer 50 gigabytes and try to upload it again. Let's see how long it will take. And you are not doing any processing. Okay, just download and upload. And this is something we will get rid of with pipelines because everything will be in our BigQuery. So that's good. Investigating phase. We didn't spend a lot of time, but we spent a lot of some time because in previous they sent only 5 files. Now they sent extra 2-3 files. So we had to understand what happened, what changed. Merging phase. Yes, that is what I tried to mention. We didn't have a problem. The same. We almost used the same code. I think we made a very small change about using the new files. But you need to understand the new files to make this small change. But anyway, merging phase is something can be automatized. Cleaning phase, data format was not consistent. Wrong dates, wrong date formats. And although we had that cleaning phase in previously, now we had to implement something new to handle the new data because we was not aware that we will have data format in a different format, in a different structure. I have no idea.
Nejari, is this a symptom when you see this in a client? Is this a symptom that, or either they don't have an organized data science team, or they're just not doing this type of analysis, or like what kind of symptoms do you see in a client that has wrong dates, that they send you one day one amount of files, the other day another amount of files?
No, I don't think it's a symptom of data science organization. It happens because if we do it today for ourselves, we will experience the same problem. I don't think it's a symptom.
It is more a normal process when you have to download data and share it with somebody.
Yeah, yes.
Okay.
I mean, maybe for example, in data science machine learning competitions, you don't see these problems because they have another data science team cleans the data and gives to you. Okay, just focus on algorithm part. Don't focus on cleaning phase, merging phase. Everything is here. Okay. So in competition, for example, they make everything ready.
When you say competition, what's competition?
Machine learning competitions. There are machine learning competitions out there, like Kaggle.
Oh, okay. Interesting.
Yeah. They make it ready. Generally, like in cleaning phase, no problem. Merging phase, again, no problem. But you have to merge. But you don't need to understand because everything is documented. So, like, but in real world, it's not working like that in a way. Processing data. Okay, again, we didn't have a specific problem processing. Do you see? Like, again, it's automatized. Perfect. We used the previous code. No problem. We process the data and convert it into the format that we want. Running the algorithm. So what do we have? Like, that is something you should be aware of. Now, the data is between 1st of January and November 30. So voice data, we have almost 3.5 million unique users that used voice, and 375 million actions. What is action? The action is Necati is calling Carlos today. It's action. Then I am calling Nati. It's another action. So I have 375 million actions in voice data. Internet data, 1.5 million unique users and 186 million actions. Very, like, these are good numbers. And after processing, we have 3 billion rows, almost 3 billion. We process it. Like, what is the processing phase? Like, that is the phase I tried to mention. We need to use our art. So for example, how I converted these 300 million actions to 3 billion rows. Here is what I am doing. I am trying to calculate the next 10 days, right? If I will churn in the next 10 days. So what I am doing is I am calculating the Nejati's actions between January 1st and January 30, and then trying to predict if Nejati will churn between February 1 and February 10. Then I am using again Nejati's information. January 2 and February 1, I am trying to predict if Nejati will churn between February 2 and February 11. Like, it is a sliding window. Is that clear for you? Do you want me to explain again, guys?
Okay.
Okay. So now you have 3 billion rows. And I think it was about 1 terabyte data. And of course, we had memory errors. But for the last, since night, we didn't see a problem. So we are expecting the result. And yeah, it has been 22 hours.
We had memory errors in BigQuery, correct?
No, in this phase. Running algorithm phase, not BigQuery.
Okay.
Okay, so there were some images here, but it seems there's a problem with the image. The image was going to show you what features we used, like average internet usage, average data usage, average voice usage, and this kind of stuff we used. But there's a problem with the image. Anyway. So that is that was just technical stuff I wanted to put.
I think
important.
it's much better that you didn't show that, because maybe this video can leak. So.
Okay. So that's it.
Nejati, one question about this. When you have that size of data, and I actually asked you this question in the channel, and let's say you are the lead data scientist or the CTO, whatever, would you run all of the data every month to know who's gonna churn, or do you just run it to train the model, and then every month you just run whatever the data is for that specific month?
So I think I would make an iteration and testing, but if you ask me, like, forget the iteration, my default action would be run every 2-3 weeks.
All the data?
Yes, probably. Like, maybe you can see something new. But my default, but I prefer to make tests to see which rules are good, which rules are bad, and use some rules.
But I think that depends also on the business model, because they were telling us that, for example, in this business, the churn and the movement of the clients, it's a lot. So they 100% need to make the analysis every month because they have a lot of movement in their clients.
No,
but
it's different, Nati. One thing is the training, one thing is the analysis of the data of that month. So obviously for the data of the month, you have to run it every day, right?
Yes, just to take I want to use the last month, and maybe there is a new change in the customer behavior. Of course, it will be hard to see in the rules, because I had 50 rules, now I had another 50 rules, maybe 20 new rules, I don't know. So how will I know which one is better? So I think it's a challenge, I believe. I don't think it is. I would prefer to iterate and make some tests and then continue with that.
So, but in general, for these type of clients would be every 2 weeks, train the model with all the data, every day run the model with the data of the past month. It's just to have like a mental model, because we're gonna have to calculate how much we're gonna charge them. And if we include into our price the server costs, it will hit us how many times we run all the data.
Yeah. Yes.
So I think that it's going to be always much better that the client pays for their server. That way they can iterate to see what works better for them.
Yeah, best option.
Because then we're going to be like in the middle, pushing them not to run more times because it's going to cost us more and our margin is going to shrink.
Yes, of course. You are right. We should, good point. We should charge them for usage.
Cool. One last question on my side, Nejari. When you say we run the algorithm, can you explain a little bit more that process of now I have my data merged or joined? I have that in BigQuery. How does that process of running an algorithm work? Like, is it just, of course it's a library that you run through code, but is that something that is in BigQuery, or do you have to move the data again? Like, what's that process?
In basic terms, it is, we are using a distributed engine called Spark, distributed data process engine called Spark. It distributes your data into different clusters and different missions in the cluster, and then makes calculations and gives the results to you back. So what is done here is basically it gets the data from BigQuery and distributes it to the memories of the cluster and runs the algorithm in the memory and gives you the result. So this is the basic explanation.
That result, where is it saved? Where do you have it? Where do you store it? Because that result of for example, in the case of Claro, is it's events, right? Like, is that something that you store in a bucket, or you store it in BigQuery, or?
In our current case, like in this Claro specific example, I don't remember if we are saving the result in the BigQuery or the bucket, but in pipelines, we are planning to use BigQuery. We will save the results rules in BigQuery because this Claro code was done separately, so I don't remember exactly where we save the result. But BigQuery will be our place that we save the rules.
One question, clients can use somehow their models made in R or Python inside our suite, inside our suite?
The answer is right now, no. But if we decide to implement that kind of stuff, we will decide. Like that is another, I think, a mix of technical and business decision, because now you are bringing people's code. They can use different purposes. Security, there are security issues. Yeah, I think that is a mix of business and technical discussion.
What was that question? Sorry.
Will people use their own Python and R code?
Oh, clients ask that question a lot, Nejari, and my answer is yes. And the reason why is yes is because how we can do it is they can run their code in whatever they have it in BigQuery, right? They have their algorithms there and they store it in BigQuery. Those results of their algorithm, they can share it with us. And we can use that to bring it as a SQL operator into our system, that specific result. And they can use it to make it actionable whenever they want.
Okay. Technically, there are no problems here, but as I said, like this is more a mixed decision of business and technical decision, and it seems Carlos already made the decision here. Because there are, as I said, technically we should be aware of security problems. Maybe the developer will use it for mining Bitcoin. Do you understand my point?
And the thing is that usually clients don't run algorithms different than the ones that Google has. So when they see, can I run my algorithm? Man, it's a linear regression. Linear regressions don't change, right?
So that's a different discussion. We will provide that kind of tools. Like, that is my input data, and that is the algorithm I want to use. Okay, we will provide this. But if they want to use their own R code, if they want to use their own Python code, that is something I am discussing. Like, we will do it, Carlos. Like, we will provide an operator that helps you to select your algorithm if you want, something like that. But as I said, like, what is that what we want? No, sorry. That's what we want. But do we also want customers to run Python and R codes, their own Python and R codes?
Yeah, like in the future, they could code their own algorithm operator with their Python code. But at the end, it's very rare that a person has their own algorithm because, again, linear regression algorithm is just one. Right, Nejati? Or?
Yes, you are right. You are right. There is no doubt here. But maybe they want to use something in process phase. While they are trying to process data, before running the algorithm, maybe they want to add make a calculation. Do you see my point? Like,
but isn't that usually done in SQL?
No, it's not usually done in SQL. It's something can be done in SQL, but it's not mandatory.
Okay.
So the answer is that we cannot connect to R or Python, but we can. They can send us what, like the code or what, in order to us to put it in our suite. I don't understand that part.
I think I don't have an answer for that. I don't know what kind of code they will run.
The answer again is if they are running something and they have a result. I guess the straightforward answer is no, you can't give us your Python code and put it in our system. You can't do that. But if you're having an output, a result based on your code that you don't want to lose, and you're storing that result in BigQuery, you can share that data with us. You can share that BigQuery database with us, and then you can bring that result via SQL code into our system.
Okay, and if they are not using BigQuery, but another, I don't know, Amazon or whatever, or even on premise, what can we do there?
We could connect, they could send the data, that result to an Amazon bucket, or I don't know, we should be able to connect to any database at this point.
Yes, we will connect anyway and move the data to BigQuery, copy the data to BigQuery.
Correct.
Okay. And one question a client asked me yesterday. So if they have to put that in an Amazon bucket, of course they have to pay for it. So they have to pay for that, for that bucket, and then for more storage in BigQuery that is going to be used by us, right?
So one thing, if today they're using a database where they have all of their data, they have to be paying something, right? Now, if they're gonna start working with us, we're gonna have to move that data to BigQuery, and we will see in our pricing, what do we charge them? Now, take in mind that storing data in a database is not expensive. Like, that's the least cost that you should worry about. Like 1 terabyte of data from Claro is just like $1 in a database. That's not the cost. What's important is the processing of algorithms. That's where the cost is. So when a client is worried of how much it's going to cost them storing the data, that should not be a thing to worry about.
Okay, good.
Nejari, if I'm saying something crazy,
No,
stop me.
You're right. You're right. The cost is processing the data, not storing the data.
But that
You're
would
absolutely right.
probably mean that the client is asking if they can translate their Python code to us in order to translate the cost of processing the algorithm to us. And that's why they don't want to run them in Python. No, Python probably costs them something, and that's why they are asking if we can process that algorithm in our systems. Could be that. Could that be the case?
No, the case is because data scientists have a huge ego, and they think that their code is, the best thing in the world.
Okay,
So
okay.
they want to preserve their results.
Okay, understood.
But again, when somebody tells you that, you have to say, oh, of course, your code is so important. Because if you tell them, hey, it's the same code everybody has, at the end, what I say is that developers and data scientists are like lawyers. They get templates from the internet and they use their brains to make it happen because everything is out there. They're not inventing the wheel every time. Algorithms are already out there. What they need to think about is more the questions that Nejari was asking. That's
Yes.
where I think the difference is.
Yes, absolutely. I was going to explain that. That is the difference. Like not the algorithm itself. How you use the algorithm is the question.
Okay, great. Thanks.
Any more questions?
But it is also a code. Maybe they are talking about, when they say code, maybe they are talking about process. I don't know. But this is a challenge anyway, of course, for you.
Anybody has any more questions? Nejari, really appreciate
Thank you very much.
for this. It was really, really helpful.
Thank you. Awesome.
Thank you. I am happy if it is
Really helpful.
helpful.
Thanks.
Okay, then I am leaving. Bye bye.
Thank you. Bye-bye.
Thank you.
Thank
Thank you.
You're
Bye,
welcome.
bye.
De nada.